The electronic instrument system on the A320 uses 6 identical display units to present data to the flight crew. 2 System Data Acquisition Concentrators, or SDACs, acquire data from aircraft system sensors and computers and generate signals to the 3 Display Management Computers, or DMCs, and the 2 Flight Warning Computers, or FWCs. The FWCs also acquire data from aircraft system sensors and computers and generate signals to the DMCs. Additional system information is provided directly to the DMCs, which process all signals received and generate the images to be displayed on each of the 6 display units. Each DMC has 2 independent channels. The Electronic Flight Instrument System, or EFIS channel, displays flight parameters on the 2 primary flight display units and navigational data on the 2 navigation display units. The Electronic Centralized Aircraft Monitor, or ECAM channel, displays the primary engine control indications, fuel quantity, the flap/slat position indicator, and warning and caution messages on the engine and warning display unit, commonly known as the upper ECAM. Synoptic information on the various aircraft systems and aircraft status are displayed on the System and Status Display Unit, or lower ECAM. Normally, DMC-1 controls the upper ECAM, and DMC-2 controls the lower ECAM. The 2 identical flight warning computers also generate alert messages, memos, oral alerts, and synthetic voice messages. They acquire data directly from aircraft sensors and systems to generate red warnings and from the SDACs to generate amber cautions and display them on the upper ECAM display unit. At the same time, a corresponding red master warning light for red warnings and an amber master caution light for amber cautions will illuminate on the glare shield panel. The ECAM control panel, located on the forward pedestal, allows the pilot to selectively display any of the aircraft system's pages at any time by pressing the corresponding push-button switch. When pressed, the light on the switch illuminates. Each of the system's pages is described in detail in the associated modules. Touch a Systems Page push button to view the desired Systems page, then the right arrow to continue. Pressing and holding the All push button switch cycles through all of the Systems pages at 1-second intervals. Touch the All push button to cycle through the Systems pages, then the right arrow to continue. On-off and brightness controls for the upper and lower ECAMs are located on the ECAM control panel, and for the PFDs and nav displays on the outboard main instrument panel. Normally, DMC number 1 supplies data to the captain's PFD, nav display, and upper ECAM. DMC number 2 supplies the first officer's PFD, nav display, and lower ECAM. DMC number 3 is in standby and available as a backup should DMC 1 or 2 fail. The Electronic Instrument System DMC selector on the switching panel has 3 positions. If there is a failure of one of the DMCs indicated by a white diagonal line across the corresponding display units, the crew can select the number 3 DMC to replace the failed unit by rotating the selector knob to the Captain 3 position or the First Officer 3 position as required. The number 2 DMC has failed. Touch the EIS DMC selector switch to select First Officer on 3. If the upper ECAM display unit fails or is switched off, the engine warning display will automatically switch to the lower ECAM. If it is desired to view a system's display page, the ECAM nav display transfer selector switch can be used to display the system's page on a nav display unit, either the captain's or first officer's. Touch the ECAM nav display transfer selector switch to view the system's display on the first officer's nav display unit, then the right arrow to continue. Another method to view a systems page when the upper ECAM display unit has failed is by pushing and holding the desired system page push button on the ECAM control panel, which will temporarily display the selected system page on the lower ECAM for a maximum of 30 seconds. Touch a systems page push button on the ECAM control panel, then the right arrow to continue. If the lower ECAM display unit fails or is switched off, the crew can again view the systems display on a nav display unit by selecting the ECAM nav display transfer switch to either captain or first officer. Touch the ECAM nav display transfer selector switch to view the systems display on the first officer's nav display, then the right arrow to continue. Alternatively, pressing and holding the desired systems page push button on the ECAM control panel will temporarily display that page on the upper ECAM. Touch a system page push button on the ECAM control panel, then the right arrow to continue. If both ECAM display units fail, selecting the ECAM nav display transfer switch to either captain or first officer displays the engine warning page on the selected nav display unit. To view a systems page, press and hold the related system page push button on the ECAM control panel to temporarily display that page on the nav display unit for a maximum of 30 seconds. Touch the ECAM nav display transfer selector switch, then a system page push button on the ECAM control panel. If a PFD unit fails or is selected off, it is automatically transferred to the nav display unit. If it is desired to view the nav display, the PFD nav display transfer push button, when pressed, replaces the PFD with a nav display. If a nav display unit fails, the PFD nav display transfer push button must be pressed to allow the nav display to be viewed on the PFD unit. The captain's nav display has failed. Touch the PFD nav display transfer push button to view the nav display on the PFD unit. The Electronic Flight Instrument System Control Panel, or EFIS panel, is located on the glare shield in front of both pilots. It is divided into two parts. The PFD control part has control knobs and a display for setting the barometric pressure and push buttons for displaying the flight director and ILS information on the PFD. The nav display part has the optional data display push buttons for displaying additional data, mode and range select switches for changing the presentation and scale, and ADF VOR selector switches for selecting raw data bearing pointers on the nav display. A fully independent clock is installed on the right side of the center instrument panel. It displays UTC, or the date, elapsed time, and has a chronometer. The digital flight data recorder is located in the unpressurized section of the aircraft tail. It stores mandatory flight data from the last 25 hours of flight on a fireproof and shockproof tape. The upper ECAM display unit is divided into two sections. The upper section permanently displays the primary engine control indications, fuel quantity, and the flap/slap position indicator. These indications are covered in detail in the associated modules. The lower section, or memo section, is reserved for the display of temporary in-flight system information and reminders, such as when the seat belt no smoking signs are on, the speed brakes are extended, or the landing lights are on. Memos are displayed in green when systems are used temporarily in normal situations, for example, when the speed brakes are extended and engine thrust is at or near idle. Some memos are amber in abnormal or undesirable situations, for example, when the speed brakes are extended and engine thrust is greater than 50% N1. Warning and caution messages, when generated by the flight warning computers, are also displayed on the lower section. The takeoff memo appears in the memo section 2 minutes after the second engine has been started. It lists key items of the normal takeoff checklist, which must be accomplished before takeoff. Required actions are listed in blue with a dashed line, and when completed will turn green. Select the auto brakes to max, then the right arrow to continue. The last item of the takeoff memo is the takeoff configuration test. Pressing the takeoff configuration push button on the ECAM control panel simulates the application of takeoff power and tests whether the aircraft is in a safe takeoff configuration. The pitch trim is not in the green takeoff range. Touch the takeoff configuration push button. If any of the listed conditions exist when either the takeoff configuration push button is pressed or takeoff power is applied, a warning or caution will be generated and displayed in the memo section. If, when the takeoff configuration push button is pressed, the aircraft is properly configured for a safe takeoff, the last line of the takeoff memo will indicate normal. The takeoff memo disappears from the memo section when takeoff power is applied. The landing memo appears below 1,500 feet if the landing gear is down, or below 800 feet if the landing gear is not down. Again, the required actions are in blue and will change to green after they have been accomplished. The landing memo disappears after touchdown when the aircraft speed is less than 80 knots. The lower ECAM normally displays various systems pages depending on the current phase of flight. The flight warning computers determine the current phase of flight from acquired aircraft signals and instruct the DMCs which systems page to display. The door page is displayed in Phase 1, but will be temporarily replaced by the APU page during APU start or the engine page during engine start. The wheel page is displayed in Phase 2, 10 seconds after the engine start sequence is complete. The flight control page will temporarily replace the wheel page if either pilot moves his side stick or deflects the rudder pedals more than 22 degrees. This may be the case during the flight control check. At the application of takeoff power through Phases 3, 4, and 5, the engine page is displayed. 1 minute after entering Flight Phase 6, or once the slats are in and climb power is selected, the cruise page is displayed. The cruise page contains information from the engine, the air conditioning, and the pressurization systems. The wheel page is displayed when the landing gear is extended through phase 9 until the last engine has been shut down, whereupon the door page is once again displayed. The bottom portion of the lower ECAM is reserved for a permanent display of TAT, SAT, time, and after the second engine has been started, gross weight. The flight warning computer classifies failures into 3 separate levels and displays them as either red warnings or amber cautions. A Level 3 warning has priority over a Level 2 caution, which in turn has priority over a Level 1 caution. A Level 3 red warning advises the crew that the aircraft is in a dangerous configuration or there is a system failure which affects flight safety. A Level 3 warning requires immediate action. The warning message is displayed on the upper ECAM and the associated systems page will be automatically displayed on the lower ECAM. The red master warning light flashes or a specific red system light will illuminate. In addition, the continuous repetitive chime, specific warning sound, or a synthetic voice will also alert the crew. A Level 2 amber caution advises the crew to be aware of the aircraft configuration or failure, but immediate action is not required. A caution message is displayed on the upper ECAM, and the associated systems page will be automatically displayed on the lower ECAM. The master caution light illuminates steady, and a single chime will sound to alert the crew. A Level 1 amber caution advises the crew to monitor a failure that results in a loss of redundancy or the degradation of a system. An amber caution message is displayed on the upper ECAM, usually without any required actions, but there is no master caution light or oral alert. Failures are further categorized into 3 types: independent, primary, and secondary. An independent failure only affects an isolated system and does not degrade the performance of other aircraft systems. An independent failure is displayed in red or amber on the left side of the memo section of the upper ECAM, with the required ECAM checklist actions indicated in blue. As each item is completed, it is usually erased from the screen. In this example, both fuel pumps in the center tank have failed. Complete the ECAM actions, then touch the right arrow to continue. Once all ECAM actions are completed and the systems page has been reviewed, one of the clear buttons on the ECAM control panel is pressed to clear the warning or caution message from the upper ECAM. This action also brings up the status page on the lower ECAM. Clear fuel by touching the clear button on the ECAM control panel. The status page displays a summary of the aircraft status and the procedures for continuing the flight with a faulty system or systems. The lower ECAM returns to the normal systems page corresponding to the current phase of flight, while the upper ECAM displays a reminder that there is information on the status page. When the slats are selected during the approach, the status page will automatically appear for review, or it can be reviewed at any time by pressing the status push button switch on the ECAM control panel. Touch the status push button, then the right arrow to continue. A primary failure is the failure of a system or item that causes the loss of use of other systems or items of equipment that depend on it. A secondary failure is the loss of a system or item of equipment resulting from the initial primary failure. Primary failures are displayed with a boxed title in either red or amber on the left side of the memo section, while secondary failures are shown on the right side of the screen in amber with a star in front of the affected system. Complete the ECAM actions, then touch the right arrow to continue. Once the ECAM actions have been completed for the primary failure, pressing the clear push button on the ECAM control panel clears the fault message and brings up the associated systems page for the first secondary failure listed on the right side of the memo section. Successive pushes of the clear push button brings up the systems pages for the remaining secondary failures. When all pages have been reviewed, the status page eventually appears. Touch the clear push button on the ECAM control panel until all secondary failure systems pages and the status page have been reviewed, then the right arrow to continue. The memo section of the upper ECAM is able to display up to 7 lines of text. If the failure messages contain more than 7 lines, a green overflow symbol appears at the bottom of the screen, pointing down to indicate there are additional lines of text available. If there are failures in other systems, the affected systems are displayed on the right side of the screen in amber or red. Remember, the flight warning computers classify multiple failures according to priority, either level 1, 2, or 3, and display them in order of importance. There is also an order of priority within each level. All available lines will eventually be viewed and cleared when performing the ECAM actions and pressing the clear push button in the proper sequence. The flight warning computer will inhibit some warnings and cautions during certain flight phases to avoid unnecessarily alerting the crew during times of high workload, such as during takeoff and landing. The right side of the memo section displays in magenta a takeoff inhibit memo for flight phase 3, 4, and 5, and a landing inhibit memo for flight phases 7 and 8. If a warning is triggered during an inhibited phase, it will be suppressed until the aircraft enters the next uninhibited phase, at which time the warning or caution will be displayed. The master warning light on the glare shield flashes red with a level 3 warning and is accompanied by the continuous repetitive chime or specific sound or synthetic voice. The master caution light illuminates steady with a level 2 caution and is accompanied by a single chime. The instinctive method for canceling the master warning and master caution lights and oral warnings is to press the light switch itself. Some red warnings, such as overspeed or landing gear not down, cannot be canceled. Pressing the clear push button on the ECAM control panel also cancels the lights, but not the oral warnings. Pressing the guarded emergency cancel push button switch on the ECAM control panel also cancels the master warning and master caution lights and any oral warnings. For level 3 warnings, the ECAM message display is not affected. However, amber cautions will be canceled for the remainder of the flight. Any canceled cautions are displayed at the bottom of the status page. Pressing the Recall push button on the ECAM control panel recalls any warning or caution messages that have been cleared in the normal process of pushing the Clear push button or that are presently suppressed due to flight phase inhibition. If there are no suppressed messages, the upper ECAM displays normal for 5 seconds. Pressing the Recall push button for more than 3 seconds displays any caution messages that have been canceled by the Emergency Cancel push button. Anytime a system parameter is out of its normal range, the associated systems page will automatically display on the lower ECAM, and the relevant parameter will pulse in green as an advisory. If an advisory message is triggered when only one ECAM display unit is operative, an advisory message will appear in the ECAM memo section and the appropriate system page push button will flash on and off. Press the engine push button on the ECAM control panel to see the advisory message, then the right arrow to continue.
In FCOM 1, at the end of each system description chapter, there is a chart titled Warnings and Cautions, which lists the possible faults associated with that system, the failure title, and if applicable, the type of oral warning, the master light, the system's display page automatically displayed, the local warning, usually a fault light on a system's push-button switch, and the flight phases in which the fault is inhibited are all listed.
The two primary flight display units display attitude information, guidance information through the flight directors, airspeed, altitude, both barometric and radio, vertical speed, heading and track, flight management guidance system modes through the flight mode annunciator, and ILS information. The following screens will give a brief description of parts of the PFD. More detailed information is provided in the autoflight, navigation, and flight control modules. The fixed aircraft symbol is black with a yellow outline and represents the aircraft relative to the horizon. The roll scale is white and has markers to indicate 0, 10, 20, 30, and 45 degrees of bank. The roll index is yellow. The top part of the pointer indicates the bank angle.
The side slip index is the lower trapezoidal part of the pointer that can move independently from the roll index. On the ground, it represents the aircraft's lateral acceleration, and in the air, it represents side slip. The color of the side slip index will change from yellow to blue in the case of an engine failure.
The airspeed scale is white on a gray background and moves behind a fixed yellow reference line and yellow triangular pointer. The minimum airspeed indication is 30 knots. The altitude indication is presented as a white moving scale on a gray background with the actual altitude in green inside a yellow window. The radio altitude is displayed below the attitude indicator when it is less than 2,500 feet. When an MDA has been entered into the Flight Management Guidance Computer for an approach, the altitude numbers will change from green to amber as the aircraft descends below the MDA. The barometric reference displays QNH in inches of mercury or hectopascals, depending on the unit selected on the outer ring of the barometric reference selector on the EFIS control panel. The inner knob sets the current barometric pressure. The display changes to standard pressure if the crew pulls the barometric reference knob at the transition altitude. The display pulses to remind the crew to change the altimeter setting if it hasn't already been set when passing through the transition altitude in climb or descent. Pull the barometric reference knob by clicking on it, then the right arrow to continue. Vertical speed is displayed as both an analog pointer and a digital number. The green analog pointer shows vertical speed on a white scale graduated at intervals of 500 feet per minute. Note the scale is not evenly graduated. The upper and lower limits represent a vertical speed of 6,000 feet per minute. This digital indication, normally green, displays the vertical speed in hundreds of feet per minute. It disappears when the rate is less than 200 feet per minute. Both the analog and the digital vertical speed indications change to amber if the vertical speed exceeds 6,000 feet per minute. The vertical speed exceeds 2,000 feet per minute during descent when the radio altitude is between 1,000 and 2,500 feet, or the vertical speed exceeds 1,200 feet per minute during descent when the radio altitude is less than 1,000 feet. The heading reference line in scale is white on a gray background and moves behind a fixed yellow vertical reference line to indicate magnetic heading. The selected heading or track is displayed as a blue triangle. The actual track symbol is displayed as a small green diamond. If the selected value is off the scale, digits representing the heading or track will be displayed on the right or left side of the scale. The localizer and glide slope deviation scales are displayed when the crew presses the ILS push button on the EFIS control panel. The deviation indices are displayed when the localizer and glide slope signals are valid. The ILS identification as decoded by the ILS receiver, the frequency, and the DME distance if available are displayed in magenta. The course pointer is displayed as a magenta dagger on the heading scale. If the ILS course is outside the displayed range of the heading scale, it will appear as a numerical value on the left or right side of the scale.
When performing a non-precision approach that is contained in the nav database, a vertical deviation scale and index are displayed on the right side of the attitude indicator. They represent the vertical deviation from the trajectory computed by the Flight Management Guidance Computer. Each line on the index scale represents 100 feet of deviation, and the scale range is plus or minus 200 feet. The vertical deviation scale will not be displayed if the ILS push button on the EFIS control panel is selected on.
The top part of the PFD is divided into 5 columns to represent the Flight Mode Annunciator, or FMA. 3 lines are available for the display of information. In the first 3 columns, the second line indicates the armed modes, and in the third line, special messages are displayed. After each mode change, the FMA displays a white box around the new annunciation for a period of 10 seconds. The first column displays the auto thrust operation mode. The second column displays the autopilot flight director vertical modes. The third column displays the autopilot flight director lateral modes. The fourth column displays the aircraft approach status or capabilities and either the decision height or MDA when entered by the pilot into the flight management guidance computer. The last column displays the engagement status of the autopilot flight director and auto thrust. Navigational information can be presented in 5 different ways on the nav display unit. The various modes are selected by using the Mode Select switch on the EFIS control panel. The ROSE modes, ILS, VOR, and NAV display information superimposed over a 360-degree compass rose. The yellow aircraft symbol is fixed at the center of the display while the compass rose rotates around it. In ARC mode, the yellow aircraft symbol is located at the bottom of the screen and only the forward 90 degrees of the compass rose is displayed. In plan mode, the flight plan legs are presented on a map oriented to true north. The center of the map corresponds to a waypoint selected by the pilot from the flight plan. The map is static, and the aircraft symbol, if visible, represents the present computed position of the aircraft as it moves along the flight plan, its orientation indicating true track. The pilot can slew the complete flight plan and view it for planning purposes. In all modes, ground speed and true airspeed are displayed in the upper left corner, as well as wind speed and direction. The digital wind information is in degrees true north, while the green analog arrow is magnetic. The arrow only appears for wind speeds greater than 2 knots. In all modes except plan, the yellow lubber line, fixed at the top of the moving white compass rose, indicates aircraft heading. The blue selected heading or track triangle shows the heading or track selected by the pilot. The actual aircraft track is displayed as a small green diamond. In ROSE modes only, small white triangles are fixed at 45-degree intervals around the circumference of the compass rose. In all modes except plan, when an ADF VOR select switch on the EFIS control panel is set to ADF, a green single-line bearing pointer for the number 1 ADF and a green double-line bearing pointer for the number 2 ADF is displayed if the bearing data is available. The bearing pointers point directly to the station. When an ADF VOR select switch on the EFIS control panel is set to VOR, a white single-line bearing pointer for the number 1 VOR and a double-line bearing pointer for the number 2 VOR is displayed if the bearing data is available. Again, the bearing pointers point directly to the station. Navigate information for ADF in green or VOR in white will be displayed at the bottom left side of the screen for number 1 receiver and the bottom right side of the screen for number 2 receiver. The first line indicates the type of nav aid selected. The second line displays the nav aid identification, and the third line shows DME distance if it is available for the selected VOR. A small representation of the applicable type of bearing pointer is also displayed next to the nav aid information. The weather radar, if on, is superimposed over the nav display in all modes except plan. There's a separate brightness control knob integrated with the nav display brightness control knob to adjust the intensity of the weather radar image. In ROSE ILS mode, the dagger-shaped magenta ILS course symbol points to the selected ILS course. The magenta localizer deviation bar moves laterally across the deviation scale. Each dot on the scale represents about 0.8 degrees of deviation. If the deviation exceeds 1/4 dot on either side with an aircraft elevation above 15 feet radio altitude, the deviation bar and the scale will pulse. The glide slope deviation scale is on the right side of the display. Each dot represents about 0.4 degrees of deviation. The magenta glide slope deviation diamond moves vertically on the scale above and below a yellow reference line. If the deviation exceeds 1 dot with the aircraft above 100 feet radio altitude, the diamond symbol and the scale will flash. The 3 lines in the upper right corner of the nav display show the ILS frequency, the selected course, and the ILS identification. In ROSE VOR mode, the course pointer is a blue dagger-shaped symbol that points to the VOR course selected by the pilot through the flight management guidance system. The blue lateral deviation bar indicates the deviation along the lateral scale. Each dot on the scale represents a deviation of 5 degrees. When the deviation is greater than 2 dots, or 10 degrees, the bar remains displayed on the outer dot. The arrow on the end of the bar represents the to from indication. In the upper right corner, the selected VOR, the frequency, the identification, and the selected course are displayed. The information presented in the ROSE nav mode and the ARC mode is the same, except that the ARC mode only shows the forward 90-degree sector of the compass rose. Navigational information, including the active flight plan, waypoints, and nav aids, are shown. In the upper right corner of the display is information concerning the next waypoint to be overflown in the flight plan, the to waypoint. The name, the track to the waypoint, the distance remaining, and the estimated time of arrival are all displayed. The range select switch on the EFIS control panel selects the displayed range scale of the on-side nav display from 10 to 320 nautical miles. The selected range fills the screen. Therefore, in ARC mode, the viewable distance ahead of the aircraft is double that of ROSE nav mode. Also in ARC mode, there are 4 range arcs, each 1/4 of the selected range. In ROSE nav mode, there is only one inner range circle, which is 1/4 of the selected range, or half of the distance to the outer edge of the circle. When the aircraft is flying the active flight plan with the auto flight system nav mode engaged, the flight plan is displayed as a solid green line. When the pilot manually selects heading or track, the flight plan will be shown as a dotted green line and the heading or track indication as a solid green line. The aircraft's lateral deviation from the active leg of the flight plan will be shown as either left or right cross-track error. The optional data display push buttons on the top of the EFIS control panel, when pressed, are used to display information on altitude and speed constraints, database stored waypoints, and stored VOR, NDB, and airport locations. Only one push button can be pressed at a time and is available only in the plan, ARC, or ROSE nav modes. Touch an optional data display push button, then the right arrow to continue. A fully independent clock is located on the lower right side of the forward control panel. It sends time signals to various aircraft systems, including the flight management computer. The clock is supplied by the 28-volt DC essential bus and is connected directly to the battery hot bus. It also has an internal battery that can last up to 50 hours in the event that the aircraft battery is disconnected. The center counter of the clock shows universal coordinated time in hours and minutes in a 24-hour format. A trend indicator on the right side of the display divides a minute into 4 15-second periods using 3 horizontal bars. For the first 14 seconds, there is no display, and after each consecutive 15 seconds have passed, a bar will illuminate starting at the top of the display. The center counter can also show the UTC date if the set push button is pushed in. The lower counter displays elapsed time in hours and minutes after the elapsed time selector is moved to run. The counter registers time of up to 99 hours and 59 minutes. The elapsed time selector has 3 positions. The run position starts the elapsed time counter. The stop position stops the counter, and the display remains at the last indication. The reset position resets the counter to 0. The upper counter displays the chronometer time in minutes after pushing the chrono push button. The sweep second hand sweeps off the second intervals. The counter registers elapsed time of up to 59 minutes. A second push of the chrono push button stops the elapsed time, and a third push resets the needle and the display. The UTC selector switch has 5 positions and is used in conjunction with the set push button. Selecting MO allows the crew to set the month and year, while DY is used to set the day. Selecting HR is used to set the hour, and MIN the minutes. The set push button can be rotated in either direction to increase the selected indication, and gently pushed in to decrease the selected indication. Pushing and turning the selector switch from MIN to run starts the clock. The elapsed time chronometer push button, when pressed, displays the chrono indication on the on-side nav display. The indication is in minutes and seconds for the first hour and then hours and minutes until 100 hours. Momentarily pressing the push button a second time will stop the chronometer, and when the push button is pressed a third time, the indication disappears from the display. Three interactive and interconnected aircraft recording systems include the Centralized Fault Display System, the Aircraft Integrated Data System, and the Digital Flight Data Recorder System. The Centralized Fault Display System allows maintenance personnel to monitor the status of aircraft systems by identifying faults through each system's built-in test equipment or byte. The system consists of a Centralized Fault Display Interface Unit, or CFDIU, inputs from the byte of each of the monitored systems, and a connection to the MCDUs, ACARs, and the aircraft printer. A post-flight report is automatically sent via ACARs to maintenance control after the engines are shut down. Failures and faults are recorded and classified according to the level of maintenance action required. A Class 1 fault is displayed to the flight crew through a warning or caution message on the ECAM or by a flag or some other obvious indication. Reference must be made to the MEL before further dispatch. Class 2 faults are displayed on the ECAM status page under the heading of Maintenance, only on the ground with engines stopped, and although reference to the MEL is not necessary, they must be noted in the maintenance log and corrected within a period of 10 days. Class 3 faults are not readily apparent to the crew and are corrected at regular maintenance intervals. Class 1 and 2 faults are automatically sent to the maintenance control via the ACARs in the form of a post-flight report, while Class 3 faults are available on request through the MCDU CFDS prompt on the index page. Various maintenance tests can also be initiated through the MCDU, and test results, fault reports, and other maintenance information can be printed out on the aircraft printer. The Aircraft Integrated Data System monitors various aircraft systems, but is mainly concerned with engine and APU condition monitoring for the purpose of corrective maintenance action. The Data Management Unit, or DMU, receives input from the aircraft systems, the CFDIU, and the FDIU. Connection to the MCDUs and printer allow for report display and system programming. The DMU also sends selected engine and APU reports automatically via ACARs during certain flight phases to the Airline Maintenance Control Department, relieving the flight crew of the necessity for performing manual engine monitoring reports. Momentarily pressing the AIDS Print push button located on the center pedestal causes an immediate printing of a specific report depending on the current flight phase. Other reports can be selected and printed if desired through the MCDU. The DFDR system has three components: the Flight Data Interface Unit, or FDIU, the DFDR itself, and the linear accelerometer installed near the aircraft center of gravity, which measures aircraft acceleration along each of the three axes. The FDIU collects and processes information from the system data acquisition concentrators, the flight warning computers, display management computers, and from the centralized fault display system, and sends this information to the digital flight data recorder. The last 25 hours of approximately 200 parameters as required by regulatory authorities and special customer requirements is stored and recorded on a magnetic tape. The tape is protected against fire for a minimum of 30 minutes and shock forces of up to 100 Gs. An underwater locator beacon is attached to the front of the recorder and is operational to a depth of 6,000 meters. The recorder ground control switch is located on the left side of the overhead panel. With the switch in the auto position, the DFDR is energized on the ground only during the first 5 minutes after electrical power has been supplied to the aircraft, or when at least one engine is running and is powered at all times in flight. After landing, it is de-energized 5 minutes after the last engine is shut down. If it is desired to power the DFDR on the ground for maintenance tests, the ground control push button is momentarily pressed to on. The blue on light illuminates. Momentarily pressing the DFDR event push button located on the center pedestal sets an event mark after an in-flight incident for ease of location on the DFDR tape.